The scientific revolution is a series of events that led to the birth of modern science. Some historians consider the development of modern science the most important event in the intellectual history of humankind. The time period in which this happened was throughout the 16th and 17th centuries. The scientific revolution was like a Plinian eruption of science, ideas, and discoveries that lasted almost 150 years and replaced the Greek view that had dominated science for almost 2,000 years. People gained knowledge by observing the world around them and coming up with logical explanations for what they saw. Johannes Kepler is one of the people who contributed to the astronomy part of science.
Johannes Kepler was one of the great astronomers in the 17th century. He founded the theory of celestial mechanics and was the first astronomer to explain planetary motion. Kepler was born in the Free Imperial City, located near modern-day Stuttgart. He was a very talented child, and his talents led to him to becoming a teacher of mathematics in Austria. Kepler was also a great mathematician and physicist and contributed to theories in geometry and optics. He also explained how the tides were influenced by the moon and founded the three laws of planetary motion. His primary discovery in astronomy, which altered astronomy's course and our knowledge of the universe structure forever, was that the Earth and other planets had elliptical orbits around the Sun.
Hi! Now let us talk about Kepler's law of planetary motion. These are the laws describing the motions of planets in the solar system. Kepler's first law of planetary motion, sometimes referred to as laws of ellipsis. An ellipse is a shape that resembles the flattened circle. A law can be stated as all planets move about the Sun in elliptical orbits, having the Sun as one of the foci. The Sun didn't sit exactly at the center of their orbit, but instead lay off to the side at one of 2 points known as the foci. Next is Kepler's second law of planetary motion, sometimes referred to as the law of equal areas, stated as a radius vector joining any planet to the Sun sweeps out equal areas in equal lengths of time. Basically, that planets do not move with constant speed along their orbits. It describes the speed at which any given planet will move while orbiting the Sun, and any planet moves through space is constantly changing. A planet moves fastest when it is closest to the Sun and slowest when it is furthest from the Sun. Lastly, Kepler's third law of planetary motion, sometimes referred to as the law of harmonies, stated as the squares of the sidereal periods of the planets are directly proportional to the cubes of their mean distances from the Sun. It compares the orbital period and radius of orbit of a planet to those of other planets. The comparison being made is that the ratio of the squares of the periods to the cubes of their average distances from the Sun is the same for every one of the planets.
One of Johannes Kepler's most important contributions to science is his advances in optics. His research into how the human visual system works and how it interprets light was crucial in the development of contemporary eyeglasses that helps both far-sighted and nearsighted individuals. He also covered the concepts of magnification and refraction, which were later applied to the discussion of how telescopes work. Also, he was the first to accurately describe how light passes through the eye's lens before being refracted and bent toward a certain focal point. Finally, despite the fact that his contributions to optics may seem modest in compared to some of his other notable achievements, Kepler is credited as being the founder of modern optics for his book entitled Astronomia Pars Optica.
Kepler's discoveries has a great influence even outside astronomy. One of them is physics. Isaac Newton's law of gravity and motion was heavily derived from Kepler's law of planetary movements. It shows that planets could be explained using mathematics and physics. A NASA mission's objective is to find Earth-like planet in origin in the Milky Way was named after Johannes Kepler. It is called the Kepler mission. This mission was so successful that in the course of its 9 years of operation, it has discovered and observed more than 500,000 stars and many planets that added up to our understanding of the worlds or the planets outside of our solar system. These are just few of Kepler's influence throughout sciences. His discoveries revolutionizes our scientific understanding of our place in the cosmos.
Kepler discovered multiple things throughout his life. He gives a massive contribution to help us understand more about it, especially in science. He established the field of optics by figuring out how the eye creates images. He also discovered how the planets orbited the Sun, leading to the formulation of the three planetary motion principles that now serve as the cornerstone of modern astronomy. While he provided an explanation for how the planets move, Kepler established the field of optics and created the first effective telescope. He looked at the night sky via this telescope. These observations allow him to identify the three rules that now are known as Kepler's laws, and which controls planetary motion.